Okay.
Hello everyone, good morning. My name is Elvin. I am speaking to you from Singapore. Today, we are proud to share with you two presentations on cell processing. The first section will be on equipment, on isolators. And the second one will be on bioprocessing via bioreactors. First of all, I want to thank you all for agreeing to join us. This is actually very challenging times due to COVID-19. So for ESCO, we will not be able to share with you like before on a very personal basis. So webinars like this will be more and more common and normal. Of course, we have many participants today. I think close to 70 people signed up for this presentation alone. So it will not be practical to answer all questions, but I will encourage all of you to have your questions typed in the chat group, and also to have a pen and paper ready to write down whatever questions you may have. We will answer all of the questions and compile all of them in this community to share with you. I would like to begin the presentation now. Today with me are my team members from European sales team. We have ESCO Pharma sales team in Singapore who will be joining us together with several other product specialists. I want to check very quickly with my colleagues. The host will be Dimitri for Eastern Europe, Elenia for Western Europe. Is my audio okay? If it's okay, I would like to proceed on with the presentation.
Yeah.
Yes, Elvin, I can hear you absolutely clear.
Very good.
Yes.
Okay, so let us begin. If you're not familiar with Teams, I hope you can manage. It's not a very difficult software to manipulate. remember, if you have any questions, please type it in the beginning. We will pause for a few moments to answer some questions directly. But my section here will probably take about 1 hour or maybe a little bit less. We will see. So this topic here is about cell processing isolator. And here would be some pictures of how this system looks like. First of all, cells are processed outside of the human body and nowadays for a lot of applications. So a lab will have several equipment that you are familiar with. Most of you are familiar with the cell culture process. But here we are trying to combine all functions of lab processing into one close integrated system. So that is the purpose of the cell processing isolator. It is an integrated system that combines several types of equipment into one isolation technology. The isolator provides very, very good operator safety as well as product quality. The air cleanliness that is achieved inside the isolator is grade A or ISO class 5. So that is actually very, very important. The applications. Now, basically, we have a few kinds of applications that we already have customers for. I will name you a few. Regenerative medicine, tissue engineering, skin graft engineering, cell therapy, cancer immunotherapy, of course, vaccine therapy. These are all applications that will be requiring more and more GMP requirement. That means it's not sufficient to actually process your cells outside of the human body and somehow introduce this to the patient without respecting GMP guidelines. GMP guidelines promote all the process steps to be done inside one integrated system. When we talk about the isolator, basically there will be some sections of the isolator that you have got to be familiar with. There will be the main chamber. If you follow my mouse, this will be the main chamber. Okay. Pass-through chamber will be this item here. This is where you introduce your product in and out of the isolator. You have the controller here that is not standard ESCO controller. It is a Siemens brand HMI PLC. What is HMI? HMI means human machine interface. Basically a controller, touchscreen. PLC, programmable logic controller. So this is a very powerful controller that actually can control not just the isolator, but all the other equipment that we connect to the isolator. And then we talk about cleaning, okay? Wiping with alcohol, blah, blah, blah. All of this is not very applicable in GMP. We must discuss the word biodecontamination. And the gas that we use is hydrogen peroxide. We have a name for our system. It's called the BioVap. We have also to monitor the environment. We have non-viable counters, which are basically particle counters. Viable counters are actually microbiological sampling counters, as well as other environmental monitoring sensors for temperature and for humidity. So this will be some of the main segments that will make up an isolator. Equipment. So we are going to talk about combining several independent equipment into one body, into one system. They will be incubators, sometimes bioreactor if you want to process a large amount of cells, a centrifuge, a microscope, and also possible to have some kind of cold storage equipment to be integrated in the isolator as well. The key thing here is all about integration. Sometimes when we have the good opportunity, we would like to sell, to promote our bioreactor. So the bioreactor have many brands in the market. Our system is very unique, and my colleague Amit will be telling you a little bit more, hopefully in a brief manner, what is this bioreactor system all about. Whatever it is, to sell a system like this, we are going to expect not to sell something off the brochure or the catalog. No, we have to expect customization and the ability to be flexible depending on the customer's requirement. What I want to emphasize now in this moment is this. There will be several applications which you may not be actually focused on right now, and the user may also not be familiar with your company in this space of GMP bioprocessing. That is why we are offering the chance to do co-technical presentation together. And this will make the process a little bit easier. All right. So this will be the main parts of the CPI. By the way, this presentation is recorded. After the presentation, you will be given a link. Okay, in this particular picture here, there will be a few items. In particular, I want to tell you a few. Here you have the HMI PLC. There will be a number 2 here will be a thermal printer. This is the black one here. You can print out reports. Number 3 will be USB ports for you to actually download the files, the reports, the logs, the data logs from the controller. You have the emergency stop button, and there will be other features here as well. In addition, there will be a few accessories. One that was not covered yet would be a microscope. And you have to actually imagine there are many other things that we can integrate as well. The process workflow is quite simple to understand. First, you start from the right. Material is actually introduced into the pass-through chamber. Material is transferred from here into the main chamber, and the process can be reversed to move the material out. Inside this space here is called the main work chamber. You can have your working involving microscope, centrifuge, and maybe other things that you want to do, pipetting, blah, blah, blah. You also have the possibility to connect the incubator somewhere here. Now, incubator, before I forget to mention this, I want to say that the position of the incubator is now shown to be on the side here, but incubators can also be connected to the isolator along the back wall as well. There will be some pro and con to do that. We just have to remember that the customer's application is most important. For example, the capacity of the samples they want to store, they want to incubate, or even how easy it is to reach the sample from where they are working in the front. Okay. Actually, a sample of a isolator, a picture. Okay. Now, I want to share with you some of the basic information about cost as well in this presentation, because it is very important to have a meaningful discussion with the customer. First of all, you will see a picture here, a full CPI. CPI is a short form for Cell Processing Isolator. It's only used by ESCO. Okay, this acronym CPI. It is 5 glove. Let me show you why it's called 5 glove. The main chamber is now shown as 1, 2, 3, 4. There's 4 gloves here. And 1 glove here will be for the pass-through chamber. The total is 5 gloves. So it looks something like this. Now, in terms of costing, again, depending on the customization, it can this amount here can change. But I want to just share with you a basic formula. For every glove that you see here, 1, 2, 3, 4, 5, okay, 1 glove is approximately 65,000 euro. So if you multiply this number by 5, this will be a total of 300/1,000 euro. If you go for something smaller, then you have to just multiply the price accordingly. But don't worry, every offer that we submit with you will be calculated, will be tabulated in a formal quotation. Now, in case you're wondering what is this 3G and 1G, let's come back here. Back this moment. So again, if you look at this picture here, you exclude the incubator for a moment. You have 1, 2, 3 for the main chamber and 1 more here for the pass-through. The total is 4. It's 4. So this will be approximately the price of the isolator. Okay. Next, I would also like to share with you that the dimensions of this isolator is actually going to be important to share with the customer. If you look at this diagram here, I want you to focus on the plan view. The plan view. So this from left to right, if you include an incubator, the main chamber and the pass-through chamber, the average left to right length that you need in the lab is about more or less maybe 3.8 to 4 meters, something like that, from left to right. Okay, and from front to back, you will need about 1.06 meters. Okay, of course, there will be some space at the back for maintenance purposes, but this will be the dimension that you will be having more or less for an incubator. If you look at the height, there's also another dimension you have to look at. The customer will always ask, what is the height? So the isolator's height itself will be about here. If you follow my mouse, it's about 2.2 meters, more or less. It can easily fit into a clean room with a typical height of 2.5 meters. So I want to say that these isolators are normally installed inside a clean room. Normally, the cleanliness of the clean room air is not as good as the isolator. That's okay. It's normally grade D at the minimum, sometimes grade C. So if you have a pen and paper, if you don't want to forget it now, please write it down. But don't worry, this is all recorded. Okay, this would be a diagram that we would like to show and share with the customer about the general arrangement of this isolator. Okay, now main chamber. Customers will ask about the size. So again, you have to understand that we in ESCO, we do not measure the size by the millimeter every single time. For the main chamber, we go by the size of the number of gloves. Example, the main chamber here in this picture, it shows you a 3-glove main chamber. So 3G for short. You can have normally 2G or 3G, 4G is typical. Okay, this is the typical sizes of the main chamber. And the chamber can be cascaded. Cascaded, that means joined together. So that's the main chamber. For the pass-through chamber, again, you can have different sizes. The pass chamber is very important to protect the main chamber. Okay, we have normally 1 glove is very common. 2 glove is also okay. 3 glove and very, very rare, but possible. Sometimes the pass-through chamber can also be very big, like 4 glove. Again, the chambers can be cascaded. That means joined together. Okay. With regards to gloves and glove ports, I just want to emphasize that this is actually about how comfortable the customer is in using gloves and how many users are actually working in this isolator. In this picture here, I'm just showing you how common configuration of the gloves is being supplied. So this will be a 3-piece glove where you have the sleeve, that's one part. In the center here, we call a connector or a cuff ring that is connected finally to a comfortable set of gloves. So in this case here, the customer can change and choose whatever size of gloves for the hands that they want. This gives you the flexibility to do that. This is called a 3-piece configuration. 3-piece configuration have pro but also con. The weakness may be that the installation of this 3-piece is not so tight. Sometimes there might be some leaks. So some customers prefer to have this to be 1 piece. That means from the sleeve all the way to the glove is 1 piece. But the con for the single piece is that you don't have the good flexibility to change from one user to another user. So for this section, we always supply our customers with a video to show them how easy it is to change the glove. Okay, now we go on to the incubator. Most of you here are really familiar with an incubator. Okay, but in this case here, we are talking about not a normal lab incubator. We are talking about a GMP grade incubator. You can take a look here. You can see significantly different from the normal incubator. Okay, first of all, we talk about the different capacity that we have as standard. So we have 60 liters. This is actually about 60 liters. We have 120 and about 200 plus liters. Okay, this incubator here is controlled by a HMI PLC. It looks something like this here. And it is actually biodecon ready. If you look at this machine here at the bottom, there is actually already a built-in biodecon system that can give you that 6 log reduction of the microorganisms. So we will cover this a little bit more later on about biodecon. Now this incubator also is completely pressure tested. It is fully with inflatable seals. It is not easy to leak, and it's very easy to connect to an isolator as shown in this diagram here. Of course, we make it in full stainless steel by default. Now, just to give you an idea, what will be the cost? A 60-liter incubator will be 20,000 euros, more or less. That is actually the price of a 60-liter CO2 incubator. Okay, a little bit more about how this incubator is connected to the isolator. You have here a transition here, and this transition is all surrounded by this white piece of material. We call it an inflatable seal. So this inflatable seal is powered up by compressed air. So when you connect the incubator to the isolator, you will activate automatically a compressed air function that will balloon up the inflatable seal to give you that air tightness. So this picture on the right hand side here shows you the inner door, the door that will be within the isolator. So there's always going to be integrity preserved. The door on the isolator and the door on the incubator cannot be opened at the same time. Okay, I repeat. This would be the door on the incubator, and this will be the door as part of the isolator. So these doors cannot be opened at the same time. Okay, unless of course everything is safe and okay. Now, microscope. Obviously, in cell processing, we need to check whether the cell is growing well or not from time to time. But it's not possible to actually have a microscope and view the image in a conventional way. So the microscope must be integrated, and not only that, there must be a good guarantee that the microscope here is waterproof, it is IP rated, and most importantly, it can withstand hydrogen peroxide, which can be quite corrosive. Okay, so there will be a need to connect this kind of microscope to a screen. Now, I want to show you the next picture here. This is actually a common configuration how the HMI looks like. So the picture on the left here will be a HMI PLC that will show you all the controls for the isolator. And then you have another screen here that will show you only the image of the microscope. So it's actually 2-in-1. It is very common, very user-friendly. Then the price of this option for microscope plus the screen, this screen here, will be about 29,000 euro. Now, there's also another possibility, and this is a little bit less ergonomic, where the only one screen is actually used, and the customer will just see the control of the isolator. But when he or she wants to see the image of the microscope, he will just have to use his finger, press an option for a microscope, and see the image. So it will be a 2-in-1 screen. But the cost is about the same. It's about the same. So this here will be the configuration, how you integrate a microscope. Okay, centrifuge. Now, centrifuge is again very integral part of the cell processing, and we think about centrifuge as a very small tabletop kind of device. But in this case here, there is a customized version we call GMP grade centrifuge. So the centrifuge actually will be very normal in terms of specification. What is the RPM? What is the rotor that you need? What is the adapter that you need? And the different accessories. All of these are the same, whether you want it to be refrigerated or not. is okay. We can discuss about this. What is the volume capacity? You know, you want 50 ml, 100 ml, 250 ml also is possible. So the process to actually understand what the customer needs is going to be there. The difference is that we must inform the customer this centrifuge, look at how it is installed, is completely airtight. It's completely airtight. It does not leak any air or any H2O2 gas, and is of course very resistant to H2O2. It is controlled also by the HMI PLC, and the cost for this, as a ballpark figure, is 22,000 euro. Now, when you talk to a customer and the customer thinks, okay, one centrifuge is 1,000 euro, 2,000 euro, please, this is not the same animal, different, very, very different. But I think we can sum up this by saying, if you want to go for GMP, then it costs money. Okay, let me show you some photos of the centrifuge. So you will see here on the surface, we cut a hole and we install the centrifuge on the work surface. There is this blue little tube here. This is actually the compressed air supply. When you open up the cover, you can already see the rotor and the adapters here. As you can see, everything here is fully welded, very smooth stainless steel surface. At the cover, you will see this blue rim here. This is actually the inflatable seal. The inflatable seal will be, again, activated to give you that airtight situation for decontamination. This is actually how the inside of the centrifuge, how it looks like. And I think that this will be a very typical a bucket, kind of a swing bucket kind of configuration, maybe 250 ml capacity, maybe at about more than 10,000 RPM. So we actually have this to show to the customer. Okay, now when you talk about samples, okay, some of the samples that go into the isolator are normally frozen. They are like ice, frozen, right? And in the lab, how do we actually, change the frozen shape of this sample to become something more soft and something more easy to manipulate? So there is this process called thawing. So thawing in a normal lab, what do? You take your frozen sample, you put it in a bath, water, and this is not very, very GMP. So the solution for this is to use a Peltier well. The 3D drawing is like this. There's a cover here. If you put your sample here, then in this well, you can control the temperature to warm or to cool. It's actually going to be very, very clean, very, very GMP. But of course, it does cost some money. 13,000 euro is the approximate price for this Peltier well. Not all customers will want to have the thawing process, but at least this system here is better than water bath. Water also is not very good to change and to have in an isolator for a long time. Of course, within the well itself, there is a need to actually use some kind of heat or temperature spread, temperature uniforming material. We call this beads, B-E-A-D-S. Is actually common to spread the temperature so that it's actually uniform. Okay, now I will show you how this is looking. Again, you cut a hole here. This will be the cover. This cover here is made from high density polyethylene. It is plastic. This handle here is removable. It's now secured with a very, very high energy, high strong magnet. And this is actually how it looks like from underneath. So you have here again a blue tubing here for compressed air. And when you activate this compressed air, then the seal around this cover here will balloon up. And that's how you achieve your air tightness here. For this concept, I think after a while it becomes very easy. Now, a little bit of some accessories that you might see. This here is called a viable air sampler. This here is the electrical outlet. Okay, so that's actually accessories that we can put. Sometimes the customer wants racks as well to put in their materials, their containers, their tubes. We can also supply them with racks accordingly. Okay, now the basic concept of an isolator will be this. Number one, unidirectional airflow, UDA. Okay, it means laminar flow. This is actually very important. Number two, single pass. That means we do not actually recirculate the air within the isolator. I will show you a diagram later on. And all of the exhaust is recommended to be exhausted out of the lab. That means through a duct. But sometimes the customer have got problem to duct. That is why we have to use a different kind of treatment, maybe using a carbon filter or a catalytic converter. We will have to see what is the situation on the clean room side. Okay. The chamber is normally positive. So unless you're handling a dangerous vaccine for cell therapy, then most of the times our customers will be requiring positive pressure chambers. The pressure inside the isolator is positive. And in order to actually have good cleanability, then we have here all the insides will be SS316L and the outside will be SS304. Everything will be smooth and single piece chamber. And we have here a diffuser below the filter to give you very uniform airflow. Very, very, very uniform. That's the basic concept here. This is how the airflow works. The air will be taken from the clean room. That's the green arrow here. It will enter into the chamber through filters. And then it will go into the main chamber. It will dilute the air here. And it will go back behind the isolator through a HEPA filter here before it's actually broken down further, maybe through a catalytic converter, and the exhaust goes out. So you have the option to actually have ducting here, which normally most customers try to do. You can see that this air here, even though it's very clean, is not recirculated back into the work zone. It's one in and one out. That is actually the summary of the airflow diagram. Sometimes customers will ask this. It's just good for us to share with you. Okay, let's go on first to some design and features, and I will just continue so that we can just stick to the time frame. Again, for you, it's just to listen. Okay, so number one, we are talking about an isolator. Every isolator starts with a pressure leak test. If the pressure is not contained and fails the pressure leak test, then we cannot proceed to the next step. So pressure leak test looks something like this. You run the isolator as a first step. There will be air that will pressurize the inside. All the gloves will extend outwards like this. And then you have got to wait and see whether the pressure stays positive for a certain period of time. Just a reminder here that in a cheap isolator, you have to do this manually. You have to climb up a stairs, a ladder, and close the damper. Or you can have fully automated pressure hole testing via the PLC. Okay, we are only offering automated pressure hole testing for convenience. Just a reminder here, this would be the cost of a 3+1 glove isolator. Okay, next, the second feature of CPI is that we use a Siemens HMI PLC. Okay, blah, 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 okay. We actually must understand that accountability, security, and traceability, these are the common words that is really, really the focus of GMP. So there is actually a requirement called 21 CFR Part 11 that must be met by the software of the isolator. There are a few things that we have to take a look at, but basically the Siemens HMI PLC does the job very well. There will be a few things here that is going to be asked for by the customer. The audit trail. I will show you. Audit trail is actually a step-by-step process workflow of a particular process of the isolator at any given time or day. It is all captured step by step. You also have to put in security access depending on the qualification of the user, whether he's a normal operator, whether he's a supervisor, or whether he's an administrator, or whether he's the engineer, or whether he's the factory. Okay, and every report that you print out, for example, the pressure hold test report, or the biodecon report, or alarms report, everything here should be, of course, signed off by the person with authority. So the report must also incorporate non-changeable electronic signature. I'm just giving you the basic understanding of it. In the past, people used to write on pen and paper a log, but actually we have to now understand the software must be producing all of this without any possibility to change the data, okay, and to erase the data. And this here is called 21 CFR Part 11 compliance, which we will provide. This here will be a screenshot of how the HMI looks like. You have, you have ESCO, of course. We can put in the customer's name. We can have all of these logos or status or icons here. You can have the name of the user, the service access, the time. You can have the different menus. So the operation will be the main one, the pressure testing, the biodecon. You can have a very graphical representation of the isolator. And you can change to check the status of the individual equipment. Example, variable air sampler, centrifuge, process chamber, pass-through chamber, microscope, whatever, okay? This menu can go on and on and on and on. Okay, that's the HMI. This would be a sample of how you check for your reports, your records, your printer setting, and your audit trail. So this here basically allows you to work to enable or disable your printer, your onboard printer. It will log a lot of information like all your data, your alarms, and your audit trail. And you can set the directory of the logs where you want to save it. You can even transfer this to a USB. You can transfer this to the building management system. And you can change the frequency of log every minute, every 10 minutes. You can configure a lot of this. There's this here. You can see that in this case here, there will be on to allow you to print out the pressure decay and biodecon cycle report. You can have electronic records and logging. That's on. You can off it if you want to. You can save all of these files in a certain directory. In this case, there's an SD card, so it's a local storage card. You can transfer it directly to a computer or something else, and this will be the logging interval. This is actually 1 minute. 1 minute is very, very common that we have this here. Now, maybe some of you have not seen what is an audit trail. This is an audit trail, right? It is many words, but basically, if somebody comes in, maybe there's some problem with the manufacturing and someone got very sick, then step by step, you will see all of this logged in by date. So by entry line, by date, and by time, and what would be the situation here, one by one. Of course, we don't want to have every unqualified people who touches the isolator to be able to operate it. So there have got to be different levels of security. And this is all password control, right? There will be, password management, user account administration, that you can, of course, have built in to this software. So some of these screenshots here, my friends, are just used to show our end users what is this whole thing all about. Okay, so we come back here to this feature, pressure decay testing. It looks something like this. You have to do it before you start work. You have to do it before you biodecon. And what is the requirement? You need compressed air. You need 6 to 7 bars of pressure, 300 liters per minute of compressed air. So ask the customer, do you have compressed air in your facility? If the answer is no, no problem. ESCO can provide a built-in air compressor, of course, with an additional fee. Okay. What is the pressure decay test? Okay, blah, blah, blah. You have the chamber filled up with compressed air. You have the pressure, holding pressure. The compressed air will turn off. You will hold the chamber for 5 minutes. And if the pressure do not go below, if the drop doesn't exceed 42 pascals, then you pass it. But let me show you what is done normally at the factory. So here you have a 30-minute process. We sample the data and check at the factory in this way. We take all of the data and we actually check for the leak, right? So there's actually a report. This is actually called Factory Acceptance Test, FAT for short. And for isolators, it's very common for the customer to want to come to the factory to actually do FAT. But nowadays in COVID-19, it's very difficult to do so. So a lot of this factory acceptance test is done online via a Zoom, video conference. Now, excluding the airfare and accommodation, an FAT process will cost about 4,500 euros. Pressure decay testing follows this particular standard. All of this acceptance criteria comes from ISO 16048 Part 2. Okay. Glove fit testing is optional, but it's highly recommended because pressure can also be lost and the integrity can also be compromised if your gloves are not tight. So we have here a function called glove leak tester. This is a portable one. This is actually something of an old configuration. Integrated glove leak tester costs about 6,000 euro, and this is actually optional. Recommended, but optional. It is one glove leak tester for one isolator. Okay, pass-through chamber has to do with inner door, outer door, and the overall size of the pass-through chamber, the overall dimension. Dimension depends on how big is your sample. Here will be the tray, movable tray is optional. It's purely optional. Whether you want or not, the price does not impact the cost. If the customer wants the tray, is included. If they don't want the tray, there's also no cost differentiation. So the pass-through chamber can have a very big dimension, very tall, very deep. It is customizable. Okay. For the glove leak tester, I want to show you that this is actually a more elegant way to mount it on the isolator body. Here you have now a concept of BioVap. Now BioVap is ESCO's bio-decontamination system using H2O2 gassing. So there will be a H2O2 chemical stored here, and the gassing is all automated, controlled by this PLC. So when we have H2O2, it is important to remove the H2O2 safely. We use a catalyst. Okay, the catalyst is called in our language a catalytic converter. So the BioVap with the catalytic converter is about 45,000 euro. Again, this is separately priced from the price of the isolator. I gave you a pricing earlier on. This pricing of BioVap is separate from the price of the isolator. Okay, for safety reasons, something else that will be also offered to the customer is actually a H2O2 sensor that we have a possibility to install somewhere in the outside environment here, just to make sure that even though we do the pressure testing, some H2O2 does not leak out during the operation. Okay. So BioVap actually is allowing you to achieve a sterilization of 6 logs reduction, 10 to the power of -6. So if you actually use a wiping with alcohol, with a wipe, you wipe, maybe you can achieve 2 log or sometimes even 3 log reduction, not more. Now, there are many other liquids that are actually going to be used in biosafety cabinets, like sodium hypochlorite. What else? Quaternary ammonium. All of this actually is good, but for isolators, we use hydrogen peroxide. So all of this here will be tested. We have to know how long we need to gas the machine. And the length of the gassing is a frequently asked question by the customer. So the biodecon process is not like few minutes you wipe, everything is okay. Sometimes it takes 45 minutes. Sometimes it can be as long as 2 hours. 2 hours, depending on what kind of materials that you use inside the isolator. If you have more items, you have more load, then you have more time. But every biodecon cycle has to be developed at a certain price. So one cycle is 4,000 euro. And every cycle here refers to a certain batch. For example, if you have a batch that have got 10 T25 flask or 5 T75 flask, okay, then with this load, how much time do you need? That's actually called one batch and one cycle development. It will cost somewhere about 4,000 euro. So if the customer have got more batch, then this will be multiplied accordingly. 2 batch, 3 batch, 4 batch. They have to cycle develop this with our support. Okay. The process is simple. You pass your pressure testing, close all the door, start your pressure testing, pass, then you inject the gas. You keep the gas constant. You stay there. It's called dwell. And then you remove the gas. That's called aeration. Okay, then this here will be the menu for biodecontamination. You can have a master decontamination where you decontaminate the whole isolator, or you can decontaminate individual chamber, process or the main chamber, or the pass-through chamber. You can select which chamber that you want. Everything, one by one. And if you look here, please ignore the time. This here is called a cycle. So for every batch, as I told you before, these numbers, it can be one cycle, number 1. Maybe here will be 5 minutes, here will be 10 minutes, here will be 20 minutes, something like that. One cycle here to develop this and to verify the result is 4,000 euro. 4,000 euro, one cycle. This is called one cycle. You can have several cycles depending on your batch. Okay. And I say the batch depends on the amount of items you put inside. Okay. So the principle is very simple. You have a bottle of H2O2, 30%. This bottle sits on a load cell, a weight sensor. So when the bottle is used, the chemical is used, and the chemical becomes less and less and less and less, then it can alarm to the customer via the HMI to say, okay, customer, please replace the H2O2. And this is how you actually spray the H2O2 into the chamber. Again, I repeat, you have here the gassing for one chamber or 2 chambers. You can choose via the HMI. Now, a little bit about the process of validation on site. So if you have on site what we call IQOQ, installation and operational qualifications, for example, by ESCO Germany, which we have now a presence, you can expect the customer to pay 7,000 euros for this service, excluding airfare. I'm sorry. I think this is actually it depends. It depends on how far is the customer from ESCO Germany, but the approximate price is about 7,000 euro, but I don't think this pricing is applicable if you know, the customer is in Kazakhstan, or Mongolia, somewhere far. Okay, so but this would be the price of IQ. IQ/OQ is similar to on-site testing, validation, commissioning. And this would be the test result. So we have two kinds of tests that we do for biodecontamination. To see the result, we need to have a biological indicator. So if this is the biological indicator, if it stays purple, it's okay, pass. If the color changes to yellow, fail. This is actually biological indicator. You have to use an incubator to check for this. You got to grow this indicator. Okay, and next will be chemical indicator. So the second indicator is CI, chemical indicator, and we have to check for color change. So if the color actually changes, okay, that means yes, there is going to be some effect of the chemical on the sterilization, biodecontamination, so it passes. If there is no color change, from here to here, there's no color change, then you actually have a fail. Okay. Particle counter is very common in isolators. You have, it looks something like this, but on the inside, you don't see. So this particle counter is this. It will be sucked using a pump, the air from here into this probe, and the counting starts here. The reading is shown here. This is actually a particle counter. This is actually how it looks like inside the isolator. Here. Okay. Now this guy here is called a viable counter. So it's actually having some kind of a filter paper here. The same concept, you will draw in the air, and then you take this paper, you just put it on media and you incubate it. So most of you will be familiar with these two monitoring devices. One is called particle count or non-viable count. This will be microbiological air sampler or viable count. The total price for these two counters is about 10,000 euros. 10,000 euros. Okay, this will be some of the HMI features that you see. You can see here that will be some continuous monitoring of the sampler. So particle count, no problem, is continuous. Air sampler is also continuous. Of course, you can program how often you want to sample the air. It is not necessary to do it every minute, every 5 minutes. It can be every half an hour, every 1 hour. We will discuss this together with the customer. Okay. This will be some test report, you know, how we check the particle count reading. Remember, we need to achieve grade A, ISO class 5 grade A. So this will be the results and the passing criteria for each particle size. Here will be a monitor of temperature and humidity. So this is actually not a control, it's a monitor. And here would be the price, about 3,000 euro. Okay. This will be how, sorry for the image, it's not very clear. This here, let me read it for you. This will be the reading for the humidity. This will be the reading for the temperature. It is shown here inside your HMI. Okay. So control system, as I mentioned before, the control system here can be confirmed. For CPI, it is a Siemens HMI PLC. Okay. If the equipment gets very long, then the PLC is mounted here on an arm, and the arm you can move left to right to make it very convenient, right? You can also have something like this, like a dual, how to say, like a monitor, small one here just on this isolator. That's possible also. This here will be the controller for the sterility testing. Yeah, it's amazing. It's we can control the operation of weighing balance or a pump via a separate remote mounting of that controller. This would be a copy of the printout of the report. Some of the reports, like in this case here, the customer wants to print out the copy of the report of the particle count test to see if it's pass or fail. So this actually is printed here from this onboard printer here. This will be the emergency stop button to stop everything. There's no charge for this. So a recap, right? Basically, you have grade A air cleanliness. Okay. For the monitoring of this, you need to have a viable counter and a non-viable particle counter. Okay. This isolator must pass pressure leak test as per ISO 1648 Part 2. All the gloves will be out. You need to have a biodecon system. Okay. The controller must be 21 CFR Part 11 compliant. Monitoring. You also will need to monitor the integrity of the filter. You need to check if the filter is fully loaded or not. This actually is monitored using a pressure sensor, what we call a differential pressure transmitter. We also need to monitor the pressure value in each chamber. We also use this differential pressure monitor. We recommend the customer use a glove leak tester just to make sure that everything is fully tight. And the inside, at the minimum, the inside is full stainless steel 316. Did you know that the guidelines for good practice to prepare medicinal products, PIC/S, is you should monitor the pressure across each filter before you start work. You should check every glove for leakages. At the minimum, you must do visual check by the eyes. But you know, ESCO don't like to check via the eyes, visual. We want to check using a proper glove leak tester here. So we have got to also perform pressure hold test before the start of each process. Okay. And reminder, monitoring of the isolator performance is critical. We must check regularly the integrity of the testing of the isolator and gloves, and we should have preventive maintenance at least once a year, Okay, as an alternative, you know, sometimes some customers are very low in budget. Then we have here this guy here, okay. Now, this guy here is called HPI Inflatable Seal BioVap. HPI means Healthcare Platform Isolator. IS means Inflatable Seal. BVP is BioVap built-in. You can see here, what is the main difference that you see? The outside here is painted. And it's two different materials. So the chamber is not single continuous piece. There will be some silicone that the customer cannot see. Silicone is used to join part A and part B together. Blah, blah, blah. The HPI platform is 20% cheaper than the CPI platform. Okay, I will show you some of the features here. We have modules, 2 glove, 3 glove, 4 glove, same thing here. You can have pass-through chamber on the left, on the right, 3 ways. 3 ways means that, you know, if this was the pass-through chamber, you can have 1 way, left to connect to this isolator, and right to connect to the other isolator. So there's 3 ways. So the pass-through will be in the center. It's possible. Okay, this will be some of the parts. It's the same like the CPI. This will be the dimensions of this. Just more or less is about that. This one here will be a cool feature, not critical. Okay, that means it will change the color of the light during biodecon. It will change the light during alarm. You will see here it's it's a very catchy. Okay. But I think so. What is going to be asked of us is our references. So all of our references are very, very sensitive information. A lot of our customers are under non-disclosure agreement. But here would be some of our customers. Okay, we have all of this here, Switzerland. But more importantly is this: a CPI can be customized from different kinds of isolator platform. Let me show you the picture here in the center. You see here the main chamber. How many gloves are there? 1, 2, 3, 4, 5. It looks very nice. It looks very continuous. But imagine this. How easy do you think it is to move this module into a clean room? It's very difficult to turn. Okay, but it's possible. Look at this here. This will be 4 gloves, one continuous piece with a pass-through chamber that is without any gloves. It's possible. Here is actually without any glove, 4 gloves. And here will be a very simple one, 2 in 1. Okay, that is actually different ways that we can have a customized of CPI. But I think for now, we don't want to be so adventurous. We want you to go to customers in cell therapy, regenerative medicine, vaccine therapy, and give us a few candidates in order for us to promote this together with you. The first few times we will do it with you. After that, you can do it on your own. Okay. Finally, how does this also help us to sell the bioreactors? And for that, I will have my colleague Amit to join in here later on. This is actually a bioreactor. It grows cells, adherent cells in large quantity. This would be a picture of how the bioreactor connects to an isolator via a liquid handling pot in a very closed aseptic way. Okay. Now is 6:05. Thank you very much. It's 1 hour. I'm thankful for your patience. Again, I'm sure you have questions. I tried my best to give you information about what this isolator is. I guarantee you there is a market in your country. I gave you prices that can help you guide the customer into a commercial discussion later on. And hopefully this can be a good start to introduce this solution for the customer. Okay, so I'm going to unshare my screen right now. Yes. I just want to check, Elenia and Dimitri, if you have captured some information about questions and whatever. I think that maybe I'm so sorry that we cannot take directly some live questions, because that will actually be taking a lot of time. But I promise you, we will come to you after this one by one. We will talk to you. We will answer your questions, maybe through a separate meeting. We will do that. We'll do that. Okay. So in the meantime, I suggest you send over your questions via the chat group. We'll try to answer them as best as possible, and we'll share all of these questions and answers with everyone. Ballpark figure, I think one system like this for the customer is about 400,000 to 500,000, maybe about 350 to about 500,000 euro. That would be the average price that will be have, and these customers can afford it, right? They can afford it. So we are after customers in the clinical side. That means they have patients. We are also after customers in the research side. They may not have a lot of money in the beginning, but networking in this area is very, very important. I strongly recommend that you look out for customers in the fields which actually we have given to you. Please go and do a Google search on where are these potential customers, go and network and really work to get us the first few meetings together with you. And I think so, our hope, fingers crossed, is to generate sales, right? Now, at the end of the day, my last point is, if the customer don't buy an isolator now, okay, maybe they say, okay, sorry, you know, the authorities is not coming after me for GMP. I can just inject with my patient with my cell processing product. I can use a normal BSC. I can use a normal incubator. I can use an open system, blah, blah, blah. That's okay. But at least we actually introduce the concept that at least we can sell other lab equipment because they are actually going to need some lab equipment as well. So hopefully it can be a win-win-win situation. We hope you will be interested in this solution. And I think that I will end my presentation now. I will want to hand over this to Amit. But before that, I would recommend maybe like a 5-minute break for, you know, to drink water, to go to the toilet, you know, and we can continue there. And Amit will just share with you very generally what do we have here for the bioreactor. Okay. Amit, are you there, Amit?
Yeah.
Oh, you're there. Okay.
Yeah.
Okay. Okay, Amit, so are you okay? We can start maybe in about 5 minutes time. Yes, it's okay?
Yeah, 5 minutes.
Okay. Thank you everyone again. Please stay safe. Please wear your mask. Okay. Yeah, and I hope to see you all I hope to see you all very soon. Yes, maybe later this year, face to face, hopefully. Yeah. Okay. Thank you. Thank you.
Thank you, Alvin.
Thank you, Alvin.
Thank you.
Dear partners, as soon as we have the short break to drink some water and hit the toilet, as Alvin says,